Dear students, welcome to this grade 9 lesson on salts. Today, our main focus will be on neutralization reaction. At the end of this lesson, you should be able to recall acids and bases, define neutralization reaction, describe the importance of neutralization in cases of indigestion, insect stings, in agriculture, and in the prevention of acid rain. Let's start by recalling acids. In grade 8, you learned that acids are naturally present in several food items. For example, lemon contains citric acid. Ascorbic acid is present in oranges. Ethanoic acid is one of the components of vinegar, while tannic acid is present in tea. Acids are not only present in food items, but they are commonly used in science school laboratories. The commonly used acids in science school laboratories are hydrochloric acid, nitric acid, and sulfuric acid. One important fact about these acids is that they all contain the element hydrogen. The hydrogen atom or atoms are chemically combined to another element or radical. We will now have a look at the formulae of commonly used laboratory acids. In addition to hydrogen, hydrochloric acid also contains the element chlorine. The valency of both hydrogen and chlorine is 1. Therefore, the formula of hydrochloric acid is HCl. Nitric acid contains hydrogen and the nitrate radical. The valency of the nitrate radical is 1. So the formula of nitric acid is HNO3. Sulfuric acid contains hydrogen and the sulfate radical. Since the valency of the sulfate radical is 2, the formula of sulfuric acid is H2SO4. You will notice that all the three acids contain the element hydrogen. As you have learned in grade 8, there is another class of compounds called bases. Similar to acids, bases also are present in commonly used items. Bases are present in baking soda, toothpaste, and soap. Bases are mostly metal oxides or metal hydroxides. Recall that a metal oxide is a compound formed between a metal and oxygen, whereas in a metal hydroxide, a metal is chemically combined to the hydroxide radical. It is to be noted that not all bases dissolve in water. The solution formed if a base dissolves in water is called an alkali. For example, sodium oxide is a base. It dissolves in water to form sodium hydroxide. Sodium hydroxide is therefore an alkali. Another example of a base is zinc oxide. Unlike sodium oxide, zinc oxide does not dissolve in water to form any alkali. The diagram on the right hand side will help you to better understand the concept of bases and alkalis. Sodium oxide, potassium oxide, zinc oxide, magnesium hydroxide, sodium hydroxide, and potassium hydroxide are all oxides or hydroxides of metals. Therefore, they are all bases. Sodium hydroxide and potassium hydroxide are also classified as alkalis since they are formed when their corresponding basic oxides dissolve in water. So we conclude that all alkalis are bases, but not all bases are alkalis. Let us now have a look at some of the alkalis present in the school laboratory. We have sodium hydroxide, potassium hydroxide, and ammonium hydroxide. Note that ammonium hydroxide is commonly known as ammonia solution. An important fact about these alkalis is that they contain the hydroxide radical. This hydroxide radical is chemically combined to an element or another radical. For example, potassium hydroxide is an alkali, in which potassium is chemically combined to the hydroxide radical. Since the valency of both potassium and the hydroxide radical is 1, the formula of potassium hydroxide is KOH. Similarly, in sodium hydroxide, we have sodium chemically combined to the hydroxide radical. The formula of sodium hydroxide is NaOH. In ammonium hydroxide, the ammonium radical is chemically combined to the hydroxide radical. The valency of both the ammonium and the hydroxide radicals is 1. The formula of ammonium hydroxide is therefore NH4OH. After studying what acids and bases are, we will now learn about an important reaction that occurs between them. This reaction is known as neutralization reaction. So what is neutralization reaction? Neutralization reaction is a reaction between a base and an acid to form a salt and water. As you may notice in the general equation, a salt and water are formed when a base is neutralized by an acid or an acid is neutralized by a base. As we mentioned earlier, bases are mostly metal oxides or metal hydroxides. Both metal oxides and metal hydroxides react with acids to form salts and water. Neutralization reaction has got several daily life applications. Let us consider the first application of this reaction. We have all gone through the problem of indigestion or stomach acidity. This problem is often the result of stress and overeating. In order to treat indigestion, antacids can be used as medicines. You may have cured the problem of stomach acidity by consuming 1 or 2 teaspoons of milk of magnesia, which is an example of an antacid. Using the information provided on antacids, can you suggest the active ingredient present in milk of magnesia? The active ingredient in milk of magnesia is magnesium hydroxide. In fact, milk of magnesia is a basic medication, which upon consumption enters our stomach and reacts with the excess acid. The reaction between the excess acid in our stomach and the basic medication is an example of neutralization reaction. We will now learn about another application of neutralization reaction, which is treatment of insect stings. Our focus will be on bee and wasp stings. When a bee stings us, it injects an acid into our body, which is the cause of the pain we suffer from. Can you suggest which class of compounds will neutralize the acid? A base will neutralize the acid. Can you now state an example of a basic substance that could be applied to the bee sting? A commonly used remedy is baking soda. On the other hand, if a wasp stings a person, it injects a basic venom into the person's body. Can you suggest which class of compounds will neutralize the base injected by the wasp? An acidic substance will neutralize the base. Can you now state examples of commonly available acidic substances used to treat wasp stings? Lemon or vinegar are commonly available acidic substances that can be used to treat wasp stings. Another application of neutralization reaction is treatment of acidic soil. Most crops grow well in neutral or slightly acidic soil. However, soil often surpasses this level of acidity due to acid rain and excessive use of fertilizers. Highly acidic soil can be treated with bases such as calcium oxide or calcium hydroxide, which neutralize the excess acid. This process is also known as liming of soil. The last application of neutralization reaction that we shall consider is treatment of acidic gases. Fossil fuels such as coal contain sulfur impurities. When fossil fuels are burned in order to produce electricity, high amounts of sulfur dioxide are produced. Sulfur dioxide is an acidic gas. Consequently, it reacts with oxygen and rainwater to form acid rain. You have learned about the different problems that acid rain might cause. Therefore, the effects of acid rain can be reduced by decreasing the emission of sulfur dioxide from burning of fossil fuels. The gases leaving the chimneys of factories are often treated with basic calcium oxide or calcium hydroxide. Let us apply our knowledge of neutralization reaction to this question. The sting of an ant contains a weak acid. Name a chemical substance that can be used to treat ant bites. Explain your answer. A basic substance, such as baking soda, is used to neutralize the acidic venom. Explanation: since the venom injected by ants is acidic, it is neutralized by applying a basic substance. Let us summarize what you have learned during this lesson. Acids are compounds containing the element hydrogen combined with another element or radical. Bases are mostly metal oxides or metal hydroxides. When a base dissolves in water, The solution formed is called an alkali. The reaction between an acid and a base to form salt and water is called neutralization reaction. Neutralization reaction plays an important role in our everyday life. For example, to treat indigestion, which is caused by an excess of acid in the stomach, an alkaline substance such as milk of magnesia is consumed. Bee stings are acidic in nature. They can be treated using basic sodium bicarbonate. On the other hand, wasp stings are basic. Therefore, they are treated using acidic substances such as lemon or vinegar. Acidic soil, caused mainly by excessive use of fertilizers and acid rain, can be treated using basic calcium oxide or calcium hydroxide. Industrial emission of acidic gases such as sulfur dioxide can be reduced by treating them with basic calcium oxide or calcium hydroxide. This lesson was presented to you by Mr. Sital Dinesh, chemistry educator. Thank you for your attention.